Good day everyone, welcome to 3D Experience 2022 launch online event of Computrends. I am Jayson. I am one of the applications engineer of Computrends who specializes in manufacturing solutions. Our presentation will last less than half an hour, so let's get started. Today, we will discuss about Solidworks Simulation. Some of you have heard of it, or some of you are already using it, and there are some who really have no idea what it is. So this is the best presentation for you to understand what and how it can help your design process. This is our agenda. First, we will know what design validation is, what Solidworks Simulation can offer, and what will be the benefits. This is a typical process without design validation software. First, we will create a product concept, build the physical prototype, and test the performance on the actual. And the process repeats from the start until the product is perfect. The downside of this process is the prototyping, very expensive and time-consuming. Nowadays, since we are living in a modern age, we are already using software that avoids producing many prototypes, which are very costly and time-consuming. We call it design simulation. So what is design simulation? Design simulation helps manufacturers verify and validate the intended function of a product under development, as well as the manufacturability of the product. Having this software, we can predict the behavior and performance of our design, avoid costly over-design, more time to innovate, and get products to market faster. Here's the proposed process of Solidworks Simulation. Create the product concept, build the virtual prototype, simulate the performance within the software, and if something needs to be changed, modification is easy and quick without spending too much on a physical prototype. Once the product performance is good, you can now build the actual prototype, or the actual product. The advantage of this process is that everything about the design is built within the software. Fewer prototypes, less costs. So here's Solidworks Simulation offers. We have different types of design simulation, and each has its own role to address the needs of every type of product development. First is the Solidworks Simulation for finite element analysis. Secondly is the flow simulation for computational fluid dynamics. And lastly, Solidworks Plastics for plastic injection mold. Let's begin with Solidworks Simulation for finite element analysis. Solidworks Simulation available to Solidworks users provide a comprehensive set of structural analysis to guide design decisions and improve product performance and quality. CAD-embedded structural analysis solutions using finite element analysis, or FEA, predict real-life performance with comprehensive capability to solve everything from a simple linear analysis of single components to complete simulations of entire assembly with contact and nonlinearities. And also, we can understand product performance early in the design process to innovate more and avoid rework. These are some of the capabilities of this software. First is static study. Static study evaluates stress, displacement, performance, and quality to avoid failure and decline over design. The factor of safety of mechanical resistance in parts and assembly is also taken into account. It also evaluates design changes to enhance product quality. Optimization. Optimization is a study that defines functional objectives as well as design variables and constraints. This will help to find the best design alternative, reduce costs, and time to market without compromising its quality and purpose. It also automatically finds the optimal design based on the design goal within allowable stress limits. Thermal study. Thermal study evaluates the temperature change of steady or temporary. It allows us to predict heat transfer effect due to conduction, convection, and radiation. Nonlinear study. Nonlinear study enables designers and engineers to validate product quality, performance, and safety throughout design creation while efficiently testing designs under stress and deformation. Solidworks Simulation integrates seamlessly into the design process, allows you to run nonlinear stress analysis directly from your Solidworks CAD model that analyzes plastic and rubber deformation beyond yield, and simulate the large effect of deflection. It also evaluates the effect of motion such as pushing, sliding, resulting in fewer expensive prototypes that reduce delays and time consuming. So despite all that, the biggest question is now, how reliable is the result of this software? Here's the answer. There's an organization called NAFEMS, an international association for the engineering modeling, analysis, and simulation community promotes the safe and reliable use of FEA technology. The initial goal of NAFEMS and the way in which it relates to SolidWorks is to generate standard benchmark by which code can be compared and to verify the accuracy of the software. As expected, there is some amount of variance, but we all understand FEA is a numerical method intended to provide approximate solutions only. Let's move on to the next topic, the SolidWorks Flow Simulation. SolidWorks Flow Simulation is an intuitive computational fluid dynamics or CFD embedded within SolidWorks 3D CAD that allows you to quickly and easily simulate liquid and gas flowing around your design to calculate product performance and capabilities. These are some of the capabilities of this software. First is the internal flow. Using this study, we can see the virtual flow within your product based on many different result frameworks. You will identify critical areas within your product at an early stage of the design. Moreover, it can calculate the pressure drop and check various configurations to find the best design to improve efficiency. Next is the external flow. This is the opposite of internal flow. Of course, the name itself describes it. Through this, we can see the virtual flow around your product based on many different result frameworks. You will identify the critical areas within your product at an early stage of the design process. Moreover, it can calculate the downforce on your rear spoiler and understand the effects of flow caused by speed and pressure distribution surrounding your product. Heat transfer or thermal stress analysis refers to a static analysis that measures the strains, stresses, and deformation that occur with changes in temperature to protect your product from overheating. Lastly, the Solidworks Plastics. Solidworks Plastics delivers easy-to-use simulation for analyzing plastic parts and injection molds. It simulates how melted plastic flows during the injection molding process to predict manufacturing-related effects so you can quickly evaluate part manufacturability while you design. These are some of the capabilities that this software could predict. First is short shots. You can visualize how far the flow front will reach your form under these circumstances. Short shots may occur when the temperature at the melt front falls below the glass transition temperature of the plastic material. A flow analysis setting temperature criteria for short shots improve the flow simulation accuracy of predicting potential short shots. Air traps. When filling the mold, it is important to have proper venting to prevent burn marks on the surface. Through this, we will know the location of the trap air in order to make the corresponding ventilation. By moving the gates or redesigning your part, you will be able to guide the air traps to a desired venting location. Runner balancing. The goal of runner balancing is consisting filling of each individual cavity at once. This can be achieved by different sizes of sprue channels. Solidworks Plastics can repeatedly calculate the optimal sprue diameter for a consistent filling pattern. Cooling analysis. The cooling function offered in Solidworks Plastics allows for greater accuracy of temperature prediction and is available in 4 models depending on the level of mold detail available to the analyst. They are responsible for producing a high-quality product with minimal warpage, which is highly dependent on the cooling stage. The uniform assumption of mold temperature is a good way to achieve a good simulation to optimize cooling system design. To verify the accuracy of Solidworks Plastics, I will show you some of the tests conducted from the virtual analysis to compare with the actual result. Here's the example of incomplete filling. The left image shows the actual product, and on the right is the virtual analysis of short shot using Solidworks Plastics. It can be seen here that the virtual analysis and actual product have identically similar in the shape of the short shots. Another example is the next slide. In this presentation, they produce different results virtually and produce the actual product. We can see almost identical shape resulting from virtual analysis and actual product. With Solidworks Plastics, you can evaluate the manufacturability of your parts and molds at the same time you design for form, fit, and function. It is great at predicting and avoiding manufacturing defects in your injection molded parts. With Solidworks Simulation, we can boost the innovation and improve the product effectiveness. Reducing costs by eliminating many prototypes helps improve process efficiency and deliver the product to the market quickly. With these capabilities, we can say that the Solidworks Simulation Suite is the design validation for all designers. So I think we're done. I hope this information helps you understand what and how this solution can help your process. Again, thank you so much for participating on our event.